Good morning, class. Good day. As promised, I will be making a PowerPoint presentation as a sort of a review before we will take a quiz on Wednesday. So, the nature of mathematics. Is mathematics invented or discovered? Raising this question during the first few days in my class last year brought up many things in the students' mind. And you know what? We ended up having a mini debate inside the class. Most of them says it's invented, but others also insisted that mathematics is discovered. I am sure that you, in your situation or your location this time, is also having your own answer to this question. Is mathematics invented or discovered? But based on what the book has said, most students are possibly not yet in a position to answer this question, especially in your level, because it takes time and exposure to mathematics to answer it with some confidence. The mathematics education students receive from schools is the proverbial tip of an iceberg. It is the finished product of a huge collection of knowledge which is hundreds or thousands of years in the making. So most students are unaware of the process that gave rise to the mathematics education they receive. In addition, the structure of mathematical knowledge itself is often hidden to students and is likely to remain so for the rest of their stay in school. The structure of mathematical knowledge begins to unravel itself when students take pure math subjects like abstract algebra and non-Euclidean geometry, but these courses are studied only by math majors. As a result, the true structure and nature of mathematics remain unknown to the larger segment of the society. Stop talking about abstract algebra and non-Euclidean geometry. These are indeed few of the most difficult courses or subject in math in the math majors for the math majors. So when we say abstract algebra, it's a collection of groups and the structures of the basic set of numbers like natural numbers, real numbers, rational numbers, irrational numbers, complex numbers, and so on and so forth. So class, is mathematics invented or discovered? Let's find out with the few evidences that we have for this lesson. I hope you will enjoy watching or learning from this PowerPoint presentation. There are three nature of mathematics outlined in the book. Letter A, it is partly invented. B, much of it is discovered. C, it is a system of knowledge. It is a collection of objects and relations among objects whose characteristics are discovered through accepted rules of reasoning. The beginning of mathematics is a human invention and is nearly as old as humanity itself. We, as Seventh-day Adventists, believe that mathematics exists even during at the creation. It began as a method to represent thoughts about quantity, form, pattern, and change. The concept of a number, for example, is an early manifestation of the concept of quantity, which gradually evolved in a primitive number system to distinguish one cattle from two cattle, three deer from four deer, one crocodile from 10 crocodiles, etc. Prehistoric artifacts at least 20,000 years old, discovered along the part of Nile River that runs through Congo, show how and why numbers may have been invented to quantify time. The Ishango bone, a fibula of a baboon discovered in the area of Ishango near Semliki River. contained notches meant to track the lunar phases in relation to the menstrual cycle of women. That is according to Zaslavsky, 1979. So this slide shows the Ishango bone, a prehistoric artifact near Semliki River in Ishango in the Democratic Republic of Congo. And Ishango bone is a fibula of a baboon. Notches were curved on the bone to track the menstrual cycle of women. These days, this thing, tracking the menstrual cycle of women, can be done through a mobile app. It has now. We can trace properly our menstrual cycle. But you might wonder why they need to track women's menstrual cycle. Okay? The reason for that is maybe to find out the cycle of these women, and because those days maybe they don't have contraceptives, they need to track the cycle to have safe like that. Okay, so this Ishango bone is one of the evidences that even ancient people uses numeration systems. They also found out sophisticated numeration systems like the sexagesimal system of the Sumerians, which were inventions of people who lived in ancient Mesopotamia. This invention goes way too far back in time. In fact, we can no longer trace the specified persons who introduced them. Historians, however, believed they were invented by scribes who acted as priests, chroniclers, and administrators of huge human settlements for purposes of managing irrigation, apportioning lands and taxes, collecting taxes, counting livestock and sacks of grains, and tracking the movements of celestial bodies. Indeed, and these things are in fact very evident in the Bible. During the time of Adam and Eve, the flood, the exile from Egypt, numbers are there already in the Bible, and we can check on them, the consistency. Even in the creation, when God numbered the days, how many days and the hours that he need to create the world, the organization of it, they are all involving mathematics. So if the identity of persons who invented early mathematics is vague at best, we are quite certain about the identity of persons who invented recent numeration systems. The modern binary system, for example, was introduced by Gottfried Leibniz in 1679 and came to be the foundation of binary logic due in large part to George Boole. So I want to talk a little bit of binary system. So this is the concept of on and off, 0 and 1, numbers represented by 0 and 1. And this is very useful in creating the motherboard, the brain of the computer. Those are just basically binary systems. So who introduced that? Gottfried Leibniz. And it was used by George Boole because we now can hear Boolean algorithm. So those are evidences of people who introduces systems of numeration. But for the ancient days, there is no such thing as certain individual who can be attributed to the discovery of number. This is a numeration system. It's talking about binary system based only on 0 and 1, and all other quantities are written uniquely as a sequence of zeros and ones. The logic of modern computers is based on the binary system, as what I have said. Leibniz appeared prominently again in connection with the birth of calculus. He and Sir Isaac Newton are credited to have invented calculus, or at least invented the early phase of calculus. Newton, for his part, invented calculus to effectively measure rates of change over infinitesimally small intervals of time. Rate of change, or instantaneous rate of change, is at the heart of differential calculus. Now, I want to talk about calculus. Many of you are so afraid of calculus, and even in the senior high school, why do some students opted not to choose STEM? Because they are afraid of the major mathematics courses offered in the STEM strand. However, class, the real concept of calculus should not be afraid of. Why? Because calculus can be used in finding the area. It's just finding the area, but this time in a non-regular pattern or shape. So example, if you need to find the area of your land which is so near the river, of course the river is not straight, it's not perfectly straight. Just imagine the Semliki River and the previous slide, it's more on curve intervals. So to find the area of your land, you need calculus at least to approximate the real area of your land. That's the purpose of calculus. It's just so hard to look at, but when you understand its purpose and how to manipulate it, it's just so easy. I tell you, one of the easiest subject in your life is mathematics. It's fixed. Wherever you go, you have the same answer to the same problem. So let's proceed to the next slide. Okay, we have tackled about mathematics as partly invented. This time, let's proceed to much of mathematics is discovered. Early Greek numeration system. These are those. Early Greek numeration system is based on the Greek traditional Greek alphabet system, but was given an antenna called keraya symbol at the end to distinguish it from true alphabets. It operated like the Roman numeral system, where the numeric values of letters are added to form a new number. So these are just the same as the Greek traditional alphabet system, but now it was added with antenna to distinguish that these are representing numbers from true alphabets. Okay, so these are the basic alpha, beta, gamma, delta, epsilon, vowel, zeta, eta, theta, iota, kappa, lambda, mu, nu, psi, omicron, pi, kappa, rho, sigma, tau, epsilon, phi, chi, psi, omega, and some p. So notice their values and the symbols. Accordingly, the initial impetus of mathematics was invention, but much of what followed next were discoveries. One of the early mathematical discoveries which had a huge impact in architecture and in the history of the development of mathematics itself is the Pythagorean theorem. Simply put, the theorem says that given a right angle triangle with legs A and B and a hypotenuse C, the sum of A squared and B squared is equal to C squared. Today, we look at the Pythagorean theorem as a relation between three numbers, A, B, and C. But ancient Egyptians and ancient Greeks look at them differently. These squares pertain to actual squares as we understand them in geometry. Let's take a look on the next slide. People invented the early counting numbers, but the succeeding propositions we have about prime numbers, the properties of numbers that arise from operations on numbers, the remainder when we divide a number by another, and many more, all these, and all properties contained in the body of mathematical knowledge that we know today, nearly all these were discovered. The foundation of mathematics was invented, but what followed next came by way of discovery. Plane geometry, also called Euclidean geometry, is a fitting example of what we speak about. As a body of mathematical knowledge, the part of geometry which is invented is the set of 5 axioms proposed by Euclid. The deliberate thought to be in mathematics by assuming these postulates to be true is an act of human invention. But the string of proven propositions, called theorems, spawned by these axioms came to be discovered through logical reasoning. See that? At first it was invented, but those remaining propositions, the discovery of theorems, they are from logic reasoning, and it was just discovered. So in this slide, you can see the Pythagorean theorem. And unlike today, when we are taught in our classrooms, these are just directly a squared plus b squared equals c squared. And sometimes we just copy the formula without understanding why it was so and why it worked in right triangles. However, the people who invented or the people who discovered this relationship really believe that these are comprised of 3 squares, okay, and they form a right triangle. Therefore, we can get a squared as the area of this side. This is c squared, and this is b squared. So you see that relationship, and this Pythagorean theorem works almost in all geometrical calculations this time. Yeah, it really worked to find relationships, to have a really accurate computations, especially in mathematics. We use the Pythagorean theorem when dealing with shapes. Okay, so let's proceed to the next.